Good day, everybody. So today I'm going to share with you a discussion video about special products. So to start with, we will have the product of a monomial and a polynomial. So if we have an expression of a times the quantity of x plus or minus y, a here is a monomial and x plus or minus y, which is it has two terms. So this is a binomial, and if you have three terms like in this example here, this is a trinomial, and if you have four more or more terms, that's a polynomial. So if you have a monomial and a polynomial, or binomial or trinomial, you just simply distribute the monomial to each term in the inside the parentheses. So you will have now ax plus or minus ay. If you have a trinomial, your monomial will be distributed to each term inside the parentheses. So you will have ax plus or minus ay plus or minus az. To further understand this, maybe let's have some example. So let's say we have 3xy squared times the quantity of negative 6y plus 25x squared z. As you can see, you have a monomial here and you have a binomial. So if you have a binomial as one of your factor, you just simply distribute this monomial to each term inside the parentheses. So you will have now 3xy squared times the quantity of negative 6xy plus, simply copy the sign, and then you will have 3xy squared times 25x squared z. Now, this is equal to negative 18x squared y cubed plus 75x cubed y squared z. This is the final answer. Now you have another one, which is 12t squared w times the quantity of w cubed minus 3tzw plus 2t. As you can see again, you have a monomial here, and then one of the factor is a trinomial. So again, you just simply distribute the monomial to each term inside the parentheses. So you will have now 12t squared w times w cubed minus 12t squared w times 3tzw plus 12t squared w times 2t. So you will have now 12w raised to 4t squared minus 36 t cubed w squared z plus 24 t cubed w, and this is the final answer. Now let's move forward to the product of the sum and difference of two expression. What does two expression means? You have this expression here, which this is the first expression, and another expression here, which is the second expression. Now, the sum and difference, it means the operation between these two terms is addition and subtraction. You just simply multiply these two expressions. Then, if you have quantity x plus y times the quantity of x minus y, this is equal to the square of the first term. So you will have x squared minus the square of the second term. So you will have y squared. So to further understand this concept, let's try to have some examples. So you will have the quantity of a squared minus b cubed times the quantity of a squared plus b cubed. First thing that you need to do is to determine which one here is your first term and which one here is your second term. And try to check if these two terms are separated by a minus sign or a plus sign for each factor. So as you can see, our first term is a squared for the first factor, and then you still have a squared for the second factor. And then you have b cubed for the first factor, and then you have b cubed again for the second factor. And the different lang of these two is the operation, which is negative and positive. So therefore, it falls to the product of sum and difference of two expressions. So with that, in this formula, we will just square the first term, which is our first term is a squared quantity square, because we need to square it, minus the square of the second term, which is b cubed is the second term, and then we will square it. So you will have a to the fourth minus b raised to 6. So this is now the final answer. Now, if you will have this expression here, try to check if you have common first terms and second terms for each factor. So you have 4xy squared for the first factor, and you have 4xy squared. At the same time, your second factors has a similar, second terms for each factors is still the same. And then, if you try to check the operation, it's negative and plus. So I think it falls to the sum and difference of two expressions. So with that, according to the sum and difference of two expression, you just simply square the first term minus the square of the second term, which is our first term is 4xy squared, quantity squared, because we need to square the first term, minus the square of the second term. So you will have now 16x squared y to the fourth minus 25s. So this is now our final answer. Or maybe you should write it this way, since we don't need to put it inside a parenthesis x squared. This is s squared. Now, let's move forward to the next example for square of a binomial. So how will you know that you have a binomial? If you have two values or two algebraic expressions separated by a plus or a minus, and then you will square it. So this is an example of a square of binomial. You have two terms and you have addition operation, and this whole two terms with this operation will be squared. So you will have quantity x plus y, quantity squared. And if you have this one as your factors, you just simply square the first term, so you have x squared plus 2 times the first term and the second term, which is 2 times x times y, plus the square of the last term, so you will have y squared. Right? And if you have a negative sign or a minus sign, you will have now the quantity of x minus y, the quantity square. You just square this you just square this binomial. This is equal to, just simply again square the first term, and the only difference lang is negative yung next operation. That's minus 2xy plus the square of the last term. Again, it's the square of the first term, so you have x squared minus 2 times the first term and the second term, so you have 2xy plus the square of the last term. So to further understand this, let's have some examples. So you have 3yz plus xz squared, quantity squared. You just simply square the first term, which is our first term is 3yz, so you have 3yz quantity square. Since it's plus, so plus, and then by default you write 2 times the first term and the second term. So your first term is 3yz times the second term, which is xz squared, right? Plus the square of the last term. So you have xz squared, quantity squared. So we just simply expand the expression. So you have 9y squared z squared plus 6y or xy z to the cube plus x squared z to the fourth. This is now the final answer. Now let's have the second one. So as you can see in the second one, the binomial is raised to 2, so it falls to square of binomial. And squaring of binomial, you just again simply square the first term. So your first term is 2m cubed n to the fourth. So you will have 2m cubed n to the fourth raised to quantity raised to 2, since we need to square the first term because it's a minus sign. So you need to write minus here. Then by default, you write 2 and then multiply the first term and the second term. So you will have 2m cubed n to the fourth times 5v cubed y squared. Then plus the square of the last term. So you have 5v cubed y raised to 2 quantity square. And now let's try to simplify. So you have 4m raised to 6 n raised to 8. 2 times 2 times 5, that's 20, so minus 20. Just simply copy everything. So m cubed n to the fourth, v raised to 3, y raised to 2, since we cannot combine anything from here on the middle term. Then square the last term, so you will have plus 25 v cubed, since it's raised to 2, so you will have 6. So you have 6y to the fourth. This is now the final answer. Now let's proceed to the product of binomial having common first term. So as you can see, you have common first terms, right? And there's two factors. This is the first factor, and then this is the second factor. So if you have the quantity of x plus a times the quantity of x plus b, this is just simply square the first term. You have common first terms, plus, always remember, get the sum of the second terms for each factor. So you have a plus b times the first term, then plus ab, which is the product of the two terms for each factor. So you will have x squared plus quantity a plus b times x plus ab. Now let's have some examples. You will have the quantity of a squared plus 5 times the quantity of a squared minus 3. As you can see, they have the common first term. So you could apply the product of two factors which it has common first term. So you just simply square the first term. Our first term is a squared quantity squared plus the sum of the second terms for each factor. So you have 5 plus negative 3 times the first term. So you have x squared plus the product of the first term, the first factor second term times the second factor's second term. So you will have 5 times negative 3. So you will just expand the expression. So you have a squared raised to a raised to 4 now, since a squared is raised to 2. Then you have plus 2a squared minus 15. This is now the final answer. So let's say that you have this expression here. You have quantity 3/3 x plus 1/2 times the quantity of 2/3. It's 2/3. 2/3 x plus 1/2 times the quantity of 2/3 x plus 1/4. So with this one, you have common first terms. Regardless of the second term, if you will have a common first term, you could apply the formula, which is you will square the first term. So you have 2/3 x quantity square plus the sum of the second terms for each expression, so that's 1/2 plus 1/4, times the first terms, you have 2/3 x. Then plus the product of the second terms for each factor. So you will have 1/2 times 1/4. So with that, this is equal to 4 all over 9x, plus this is 1/2 plus 1/4, that's 3/4, right? So cancel it all. So cancel to. You have 1, then you have 2. So you will have 1/2 x plus 1/8. So this is now the final answer. Since 1/2 plus 1 times 1/4, that's 1/8. Now let's proceed to the next one. The product of two binomials that have no common terms. So if the two factors, they don't have common terms for each factors, no? If lahi yung or iba yung mga values nila, so you just simply use the FOIL method. In FOIL method, in operating all the factors, you need to do the first term first, or multiply the first terms to each factor, and then outermost terms, and then innermost terms, and lastly, you will try to operate the last term. So let's say that you have quantity x plus u times the quantity of y plus v. So since they have no common terms, so you just simply do the FOIL method. You do the first term first, so these are our first terms. You just simply multiply this one. So you have the first term, and now the outermost terms. So this is the outermost terms for the first factor, and this is the outermost terms for the second factor. So this, you need to multiply it. So this is the outermost term. So you will have now x times y plus v times x, or you could have x times v. It's still the same. V is equal to v times x. It's still the same. And now you will do the innermost terms. So you have here u times y. Okay, that's the innermost terms. And lastly, you will do the last terms. That's u times v. So this is the last terms. Okay, so you will have that FOIL method. So let's have this example. For the FOIL method, you have quantity 3a squared y plus 2b cubed times the quantity of 3a squared minus 4b cubed. Again, if you try to check this, the terms are not the same. They don't have common terms for each factor. So with that, you may use the FOIL method. So let's start with the first term. So you have 3a squared y times 3a squared. Then the outermost term. So just simply write plus, and then on each factor, each term for each factor, you just simply copy the sign. So you will have plus 3a squared y times negative 4b cubed. Then we will do the innermost terms. So you will have plus 2b cubed times 3a squared. And then the last terms. So you will have plus 2b cubed times negative 4b cubed. So we just simply simplify everything. So you have 9a to the 4th y plus, since it's minus, so you have minus 12 a squared b cubed y plus 6 a squared b cubed plus, minus negative 8 siya, so that's minus 8 b raised to 6. So now I think we cannot simplify or combine like terms since it doesn't have any like terms. So this is the final answer. Now let's move forward to this one. So you have the quantity of 4uy squared plus 2d times the quantity of 6y to the fourth u squared minus 2d cubed. As you can see, they don't have common terms, so we just simply do the FOIL method. So first term first, you have 4uy squared times 6y to the fourth u squared, then plus the outermost term, so you have 4uy squared times negative 2d cubed, and then the innermost terms you have to do plus times 2d times 6y to the fourth u squared, then plus the outermost term, so you have 2d times 2d cubed, and then let's try to simplify. So you have 24 e raised to 3 y raised to 6 minus 8 u, then you could write y squared d cubed, and then plus 12 u squared dy to the fourth, then plus 4d to the fourth. So I think that's the final answer. Now let's proceed to the next one. Now let's have the square of a trinomial. So you will know that it's a trinomial if you have two values separated by two operations. Three values, three values separated by an operation, two operation. So with that, you have the quantity of x plus y plus z times quantity squared. Since it's a square of a trinomial, just simply square this whole thing. So you just simply square the first term, so you have x squared, plus square the second term, that's y squared, plus the square of the last term, you will have now z squared. And then plus 2 times x times y plus 2 times x times z plus 2 times y times z. It's like ito, plus 2xy, ito, plus 2xz, and then plus 2yz, right? That's the square of a trinomial. So with that, let's have some examples to further understand this. So you will have the quantity of 4u squared plus 3/4 y cubed minus 2z squared quantity squared. So it falls in the square of a trinomial. Now with that, you just simply square the first term. So you have 4u squared quantity squared plus the square of these middle terms. So you have 3/4 cubed y cubed raised to 2 plus negative 2z squared quantity squared plus 2 times the first term and the middle term. So you have 4u squared times 3 all over 4y cubed, then plus 2 the first term and the last term. So you have 4u squared times negative 2z squared plus 2 times the middle term, 3/4 y cubed times the last term, which is negative 2z, it's 2z squared. So let's just simplify. You have 16u to the fourth plus 9 all over 16y raised to 6 plus 4z to the fourth. This is equal to cancel ito. So you have plus 6u squared y cubed, then minus That's 4 times 2 times 2, that's 16, right? So negative 16 u squared z squared, and you will have, so cancel, this is 4, 2 times 2, that's 4 divided by 4, so you will just have 1, and then negative 1, sorry, so you will have negative 3y cubed z squared. So I think this is the final answer since you cannot combine anything. Alright, now let's have the next one. So again, you have 3 terms separated by 2 operation, and then the whole entire expression will be squared, and this is a square of trinomial since you have 3 terms. So just simply square the first term plus the square of the second term. So you have x squared quantity squared plus 3y raised to 4 squared plus w squared quantity squared. Then plus 2 times the first term and the middle term. So you have x squared times 3y to the fourth plus 2 times the first term times the last term plus 2 times the middle term. It's 3y to the fourth times w squared, which is the last term. Now let's just simplify. This is x raised to 4 plus 9y to the 8 power plus y raised to the fourth plus 6x squared y to the fourth plus 2 times x squared w squared, then plus 2 times 3, that's 6, so 6 y to the fourth w to the second power. So I think this is the final answer. Now let's move on to the cube of a binomial. So you will know that it's a cube of binomial if you have 2 terms separated by an operation. It's either minus or plus, and then the whole expression will be raised to 3. So we have now the quantity of x plus y, quantity cube. This is just equal to this expression here. We just cube the first term, that's x cubed, plus 3 times the square of the first term times the second term. So you will have 3x squared y plus 3 again times the first term times the square of the second term. So you have 3xy squared plus the cube of the last term. So you will have now y cubed, right? So if you have an expression looks like this, which it is quantity x minus y, quantity raised to 3, it's still the same with this one, but then the difference lang is the operation. It will be plus, minus, plus, minus. It will be alternating. So you will have x cubed minus 3x squared y plus 3xy squared minus y cubed. So to further understand this, let's have this example. So you have the quantity of 3v to the fourth power y minus 3x squared quantity raised to 3. So this is an example of the cube of a binomial. So you just simply cube the first term. So you have 3v to the fourth y quantity raised to 3. Since it's negative, the signs are alternating. So you have positive here, and then you have negative 3 no, times the square of the first term, so 3v to the fourth y raised to 2 times the second term. Since we already changed the sign, you just simply copy the coefficient at the same time all the variables within the term. So you have 5x squared plus, since it's alternating, it's plus minus plus 3 times the times the first term. So you will have now 3v to the fourth y times the square of the second term. So you have 5x squared quantity squared. Then minus the cube of the last term. So 5x squared raised to 3. So you will have now 3 times 3 times 3, that's 27. V raised to 12, y raised to 3. Minus, that's 3 times 3. I'll just get my calculator one moment, since I need the cycle for these numbers and for the next examples. That's 27 times 5. That's 135. So 135 x squared v to the fourth up. That's v to the sixth power. Since we need to square it. Sorry, 8 power. V raised to 8 power, y raised to 2. Then we have plus 3. That's 25. Since it's 5 squared here, so that will be 25 times 3 times 3, that's 225. So you have 225 v raised to the fourth y times x raised to the fourth. So that's okay with me if you rearrange the variables. Then minus 5 cube is equals to 125. It's x raised to 6. So this is now the final answer. Now, if you will have quantity 4u squared plus 2 all over 5y, quantity raised to 3, still it falls in the cube of a binomial. So you just simply cube the first term. So your first term is 4u squared, quantity cube. Since it's plus, so all the operation will be addition. So plus 3 times the square of the first term. So you have 4u squared quantity squared times the second term, which is 2/5 y, plus 3 times the first term. So you have 4u squared times the square of the second term. So you have 2/5 y quantity squared plus the cube of the last term. So you have 2/5 y raised to quantity raised to 3. So we will have now I think 4 times 4 times 4 is 64. E raised to 6. Then, it's 4 times 4, since it's 4 squared, times 3 times 2. So you have plus 96 all over 5. Okay, since you have 4 squared times 3 times 2. It's 46 divided by 5. So you have 96 all over 5. U raised to the fourth power y. Then you will have 4, 2 squared, that's 4. So you have 4 times 4 times 3. Then you have the denominator here will be squared to 25. So plus 48 all over 25. Just input it in the cycle, no, in your cycle, so you could easily get the value for this multiplication. So you have 48 all over 25 u squared y. Then that's plus 2 times 2, that's 4 times 2, that's 8. So 2 y raised to cube. This is y u squared y squared ito. I think it's okay. Yeah, it's okay now. So that's u squared y squared plus 8 cube all over, since 2 times 2 times 2, just 2 cube, yeah, it is equals to 8. if you have 5 cubed, that is equals to 125. So I think this is now the final answer. Now let's move forward. I think this is the last one. It is the product of a binomial and a trinomial. So if you will have the quantity of x plus y times the quantity of x squared minus 2xy plus y squared. So you have quantity x plus y times x squared, quantity x squared minus 2 minus xy plus y squared. This is equal to x cubed plus y cubed. How will you know that? If this is your binomial and this is your trinomial, you need to identify first your binomial. What is the first term and the second term? And if you try to look to your trinomial, is this expression is the square of your first term? Yes, that's x squared. Is this expression is the product of your first term and the second term? That's yes. And is this expression is the square of your last term? Which is yes, which is y squared. And if it's plus, it will be minus plus. Okay, the sign in the trinomial will be alternating. That's plus minus plus. And if you will have negative, same thing. But the difference lang is the expression here inside the trinomial. The operation should be plus plus or addition. So if you have quantity x minus y times the quantity of x squared plus xy plus y squared, this is just simply equal to the cube of the first term minus the cube of the second term. So again, always remember the basis is your binomial. Is this term ba is the square of your first term, which is yes, that's x squared. Is this term ba is the product between your first term and the second term, which is yes, that's times x, plus x times y. And then is this the term which your second term here in the binomial will be squared, which it is, so y squared. Now, let's have this expression here. We have the quantity of 3x plus 4y times the quantity of 9x squared minus 12xy plus 16y squared. Right, try to check. This is your binomial and this is your trinomial. So we need to set our binomial as our basis to check if we could satisfy the equation. So since it's plus, it should be alternating with regards to the operation of the trinomial. That's positive, negative, positive, which is right. Now let's try to check each term. Is this term is the square of the first term, which is right. Is this term will be the product between the first term and the second term, which is right, which is if you have 3x times 4y, you will have 12xy. And then is this term will be the product between, will be the square of the last term, which is right. Since if you will have 4y quantity squared, that's equal to 16y squared. Therefore, we satisfied, or this expression satisfied the equation. So just simply, since it's plus, you will have plus as the operation. So with that, you just simply do this. So instead of getting it immediately, right, the process of how you come up with the answer. So you have quantity 3x plus 4y times 3x quantity squared, which is it is equal to 9x squared minus that's 3x times 4y, which it is equal to 12xy, and then the square of the last term, so plus Since alternating on sign, just simply copy it, pag plus 4y quantity squared, which it is equal to 16y squared. So this is equal to the cube of the first term plus, since it's plus, the cube of the last term. So you will have now cube of 3, that's 27 cube, plus the cube of 4, which is 64y cubed. So this is now the final answer. Now let's move on to the quantity of 4y cubed y minus 2z times the quantity of 16x raised to 6 y raised to 2 plus 8x cubed yz plus 4z squared. So as you can see, let's try to check first if this one satisfies the equation or formula. If it doesn't satisfy the formula, well then we will do FOIL method, right? So this is the first term, this is the second term, and this is the first term for the trinomial. So is this first term in the trinomial satisfies the equation? Let's try to check. The square of x 4x cubed y, okay, it's equal to 16x raised to 6y raised to 2. That's right. So if we will have now 4x cubed y minus 2z times the first term, which if we will try to cube the first term of our binomial, this is equal to 4x cubed y quantity squared, which this is equal to 16x raised to 6y squared, which is right. Then the middle term for the trinomial should be the product between the first term and the second term in the binomial na factor. So since it's minus, you will have plus. You just simply copy the operation. Plus 4x quantity 4x cubed y times the 2z. So is this equal to 8x cubed yz? So you have 8x cubed yz, which it satisfies the middle term for the trinomial, plus the square of the last term, which is our last term is 2z quantity squared, which this is equal to 4z squared, which we already satisfied the formula. So since it's minus, you just simply write the cube of the first term. So you have 4x cubed y quantity raised to 3 minus, since it's minus, and then you have 2z quantity raised to 3, cube the last term. So you will have now 64x raised to 9. I simply multiply the exponents. You will have y raised to 3 minus 8. That's 2 times 2 times 2. That's the cube of 2, which is 8. Then you have z cubed. This is now the final answer. I think that's it for my discussion video about factoring, and thank you so much for listening.